Now, let's look at some examples of graphing linear inequalities. This equation that we just graphed would form a straight line, y-intercept of 3, up 1 over 2, up 1 over 2, up 1 over 2. We can also go to the left, but all of the points that make this statement true are ones that are on this line. Now, if they are on this line, they're going to make that statement true. But now, I took this equation and changed it slightly. I made this y is greater than or equal to 1/2 x plus 3. Now, we know how to handle the equal part. We'll deal with the greater than in a moment. So I'm going to graph the equal part, and then we get all the points that are on this line. But now we're looking for all the points where y is not only equal to this, but it could be greater than. As I said earlier, that this coordinate plane has been cut up into two half planes. So I'm just going to choose a point like this guy right here, 0, 5, 0, 5. And I want to know if that point will make this inequality true. Now, half of 0 is 0 plus 3, and 5 is greater than 3. So this point makes the statement true. So I should include that point as a possible solution to this inequality. How about, let's take 2, 5. 2, 5. Now, if I take 2 and plug it in here, half of 2 is 1, plus 3 gives you 4, and 5 is greater than 4. So this point should also be included. Now, if I started taking all the points, any point in this half plane, they would all make this statement true. And so what we get then is there are so many points above this line that instead of graphing each one of them, we just shade, and that shading represents all the points that will make that statement true. Now, you might say, well, how do we know we shouldn't shade this part? Well, let's pick a point. The easiest one here would be the origin. Half of 0 plus 3 is 3. Now, if I chose 0, 0, then the only reason that I should include this to be shaded is if it makes that statement true. Is 0 greater than 3? No. Is it equal to 3? No. So this point should not be shaded. And if I choose any other point on this side of the line, it will not make that statement true. Now, another way to think about it is if you put your pen or your pencil on any one of these points on the line, and then think to yourself, okay, y is equal to 1/2 x plus 3. As I move up, my y value is getting bigger, and that's what we want, y to be bigger than or equal to 1/2 x plus 3. Now, let's go down here to this next example, 2x minus 4. Okay, so we know how to graph that. 2x minus 4 has an intercept of -4, and it has a slope of 2. And so if I graph all of those points that make that statement true, I'm going to get a straight line. So I'm going to do the same thing here. We know how to handle the equal sign. And now let's handle the greater than portion. We want all the points where the y value is greater than or equal to 2x minus 4. If I put my pen or pencil at any one of these points, I want where y is greater than 2x minus 4. So that would be everything shaded above that line. And once again, I get all of these points in this half plane. Now, you could check any point over here, and you'll see that it will not make this statement true. Okay. For example, let's just take this point, 5, 0, 5, 0. 2 times 5 is 10, minus 4 is 6. Is 0 greater than or equal to 6? No. So this point is not included in our solution set. We will not shade this part of this half plane. We will shade the other part. Okay, now the next example, we have negative 2/3 x plus 1. Okay, so my intercept is 1, and I'm going to go down 2, right 3, down 2, right 3, like this. And it says y is equal to. So if I graphed that equation, I would get a graph that looks something like this. However, this time I have y is greater than negative 2/3 x plus 1, but it's not equal to. So we need to come up with some way of describing everything above but not including that line. So instead of using an open circle as we did on the number line, we are going to use a dotted line. So when we put these initial points as a frame of reference here, what I'm going to do is, instead of drawing a solid line, I am going to draw a dotted line. And that dotted line represents a barrier between this half plane and this half plane. But as we did in the other graphs, we want y to be greater than. All along that line it's going to be equal to. We want it to be greater than. So now I'm just going to shade everything above that line. Okay. Now some people, when they draw the graph here and they shade, they stop shading when we get to the edge of the graph. But you don't have to do that. Feel free to shade, because that coordinate plane extends in all directions. Now, here I've got 2 more, and then we're going to summarize slightly. Y equals opposite of x plus 2. So I'm going to start at 2, and my slope is negative 1. So it's going to look like this, and I get a line as you might expect. This time I have y is less than. Now, less than is going to be different than the greater than, because instead of shading above the line, we're going to shade below the line, because we want all y's to be less than the opposite of x plus 2. And as in the previous problem, when this is a less than, it's not including the line. So even though it looks similar, once we get these points as a reference, then we're going to draw a dotted line through those points. And if you put your pencil anywhere on this line, and then we want y to be less than that. So we're going to shade everything below that line, and it would be everything on this part of the graph. Okay, so let's summarize here a little bit. If it's less than or greater than, then we're going to have a dotted line. If it's less than or equal to, greater than or equal to, then we will have a solid line. Now, if the equation is written in slope-intercept form, then we're just going to shade above or below the line, depending on if it's greater than or less than. Again, that line divides the coordinate plane up into two half planes. But we also have some special cases here to deal with. Special cases are vertical lines and horizontal lines. So if you remember, let's take x equals 3 for example. X equals 3 would be a vertical line at x equals 3. We don't care about the y value. We could have points like 3, 0, 3, 1, 3, 5, 3, negative 2. These are all points on this line. But if you notice, the coordinate plane has been cut up into two half planes, but there isn't an above or below. There is a right side and there is a left side, but there's not an above or below. So when I graph an inequality of a vertical line, then it could take on a form such as this. X is less than 3. Now, we would still have a vertical line, but instead of this line being solid, it's going to be dotted. And then we want all x's to be less than 3. So what we get then is all points to the left of that vertical line. And it would be everything shaded to the left. I'll take my, my highlighter here. Everything to the left. Now, if this would have been x is greater than 3, then it would have been shaded everything to the right. Now let's look at horizontal lines. Suppose we had x is equal to negative 2. Okay, that would be a horizontal line through negative 2. But suppose I have greater than negative 2. Greater than tells us that it's not equal to negative 2. We do not want a solid line. We want a dotted line. So this is going to be a dotted line. And then we want all y values to be greater than negative 2, like negative 1, 0, 1, 2, 3, 4, but nothing where y is less than negative 2. So it's going to be everything above, and I had said that can't be less than negative 2. It can't even be equal to negative 2. It's going to be everything above negative 2 here. And if we choose a point on this side of the line, or in this half plane, for example, 2, 5, notice that the y value is greater than negative 2. 5 is greater than negative 2. If I pick an arbitrary point on this side, y is negative 5, and y is negative 5 is not greater than negative 2. So this point is not in our solution set, only the points that are above that dotted line. Okay, let's do a few quick examples then before we quit here. Y is less than 3/4 x minus 2. Now, I know how to graph y equals 2, but this less than tells me that I'm going to have a dotted line. So I'm going to start at negative 2, and I have a slope of 3/4, 3/4, and this would be 3/4 like this. So now I have those points as a reference, but now instead of drawing a solid line, it's going to be a dotted line. And then we want all the points where y is less than 3/4 x minus 2. So it will be all the points less than this, or that will be below that dotted line. For number 4, I'm going to slide a 1 in here to tell us that our slope here is 1, and it goes through 2. So the intercept is 2. We go up 1 over 1 like this. And since it's greater than or equal to, this will be a solid line. And so now it's a solid line. Looks like this. And we want all the y values to be greater than x plus 2. And that would be all of the y values of the points that are above that line. Y is greater than 4. This is a special case. It's a horizontal line. So I'm going to draw a horizontal line through 4. And then y is greater than 4. So I want y to be greater than 4. So I'm going to shade everything above that horizontal line. X is less than negative 2. Again, this is a special case. This will be a vertical line. And since it's less than, it's going to be a dotted line through negative 2. And then we're going to shade everything. We want x to be less. Here x is greater than negative 2. Here x is less than. So we're going to shade everything to the left of negative 2. Now I just added 2 problems down here just to stretch your thinking here a little bit. Notice that this looks like standard form, and yet we have an inequality here. So I'm just going to rewrite this by subtracting 2x from both sides. And then I get y is less than negative 2x plus 5. And my y-intercept is 5. My slope is negative 2. And since it is less than, this is going to be a dotted line. So I'm going to draw a dotted line through those points. And then we want y to be less than negative 2x plus 5. Now, if we shade all the points where y is less than negative 2x plus 5, that would be all the points that are below that line. Now, if we chose a point, such as the origin, we could double check and make sure that this makes the statement true. Is 0 less than 0 plus 5? 0 is less than 5, so the origin, which has the coordinate 0, 0, should be in the shaded part, and we're going to shade below that line. Now, the steeper the line, the harder it is to tell above or below. But if you put your pen or your pencil on the line and you go straight down from each point, then you can often see where it is going to be shaded below. Now the last one goes back because we need a few rules from earlier on. I'm going to subtract 2x from both sides, and then I would have negative 3y, is less than negative 2x plus 12. So when I subtract 2x from both sides, I get negative 2x. Now I'm going to divide by negative 3. And when I do that, when you divide by a negative, you have to reverse the inequality. A negative divided by a negative is positive. And when I divide 12 by negative 3, I get minus 4. And so negative 4 is my intercept. I'm going to go up to over 3, up to over 3, up to over 3. And it is greater than, so it's going to be a dotted line. And I am going to shade everything above that dotted line. And just like I did over here, I'm going to choose 0, 0. And notice 2 times 0, 3 times 0, right? Using the x and y here. Is 0 less than 12? Yes. So 0, 0 is included in the shaded portion.